Earlier this year, we did a lab where we took solid magnesium and heated it in a crucible to a very high temperature in the presence of oxygen gas in the air. As a result, we got magnesium oxide. In this example, we'll do some stoichiometry calculations to find how much magnesium oxide we would expect to get from a certain amount of magnesium, and then to look at how one would calculate percent yield. So to start, let's assume that we began with 1.50 grams of magnesium. Okay. Now, before we go anywhere, we need to make sure that we have a balanced equation. So let's check. On the reactant side, we have 1 magnesium, and on the product side, we have 1 magnesium. On the reactant side, we have 2 oxygens in the form of O2 and 1 oxygen in magnesium oxide. So we need to put a 2 in front of our magnesium oxide to balance our oxygen. But now our magnesium is out of balance. We have 2 on the product side, but just 1 on the reactant side, so we need a 2 in front of that magnesium as well. Now our equation's balanced. First, we want to find out how many grams of magnesium oxide we would expect to get in an ideal reaction. When we do stoichiometry calculations, we are finding the results in an ideal reaction. As we know, things in the real world are seldom ideal, so our experimental yield is usually different, but we'll get to that later. So first, we need to find the molar mass of magnesium so that we can go from grams of magnesium to moles of magnesium. In order to do this, we'll go to our periodic table and we'll find magnesium, element 12, has a molar mass of 24.31. Now that we've gotten from grams of magnesium to moles of magnesium, we're ready for our molar ratio. We'll want to go from moles of magnesium to moles of magnesium oxide. Remember that we get our molar ratio from the coefficients in our equation. So we look and see that we have 2 moles of magnesium to 2 moles of magnesium oxide. Now that we're in moles of magnesium oxide, we need to calculate the molar mass of magnesium oxide so that we can find the grams. To do this, we add the mass of the magnesium, 24.31, to the mass of oxygen, 16.00, which we can find on the periodic table, and find that the molar mass is 40.31 grams per mole. Now we can quickly do our calculations to find out how many grams of magnesium oxide we could expect to produce if we started with 1.5 grams of magnesium. Once those numbers are punched into your calculator, you should find a result of 2.487248. Now, how many significant figures can we have? If we look, we see that we have 1.50 grams of magnesium, so we can have 3 significant figures. So 2.49 grams of magnesium oxide is our correct expected value. Now that we know in an ideal reaction how much magnesium oxide we could expect to get from 1.5 grams of magnesium, we could go into the lab and do this experiment. Now, let's say, for example, that we got 2.25 grams of magnesium oxide when we did the experiment. We would want to know what our percent yield would be. Percent yield is calculated very simply by putting the actual value over the expected value and multiplying by 100. So in this case, we would point 2.25 grams of magnesium oxide as our actual value over 2.49 grams of magnesium oxide as our expected value, and we would multiply that by 100. We would find our result to be 90.4% yield. So when calculating percent yield, you need to know first, how much of a specific substance could you expect to get in an ideal reaction? So that's the calculation we did at the beginning. Ideally, we could expect to get 2.49 grams of magnesium oxide from 1.5 grams of magnesium. Then you need to know what your actual value was. So in the lab, we got 2.25 grams of magnesium oxide. Then we put our actual value over our expected value and multiply times 100 to get our percent yield.